Good morning, my dear students of first secondary. Today we are going to talk about a new trigonometry lesson. This lesson is called trigonometric function. One of the important lessons in trigonometry today is trigonometric function. Let's go. Trigonometry, Lesson 3, Trigonometric Functions, prepared by Mr. George Milad. Definition: the unit circle. The unit circle is a circle, its radius equals 1. So, the radius, the unit circle is a circle. Its radius equals 1 unit and its center is the origin point. Here in the opposite figure you can see the unit circle. Here this is the unit circle. Its radius equals 1. So the radius of the circle is equals 1. Okay? And its center is the origin point. So this is the unit circle, and you can see that the unit circle intersects x-axis. Here the unit circle intersects x-axis at the point 1, 0 and intersects x dash at the point negative 1, 0. And also the unit circle intersects y-axis at the 2 points 0, 1 and 0, negative 1. Okay? Here, very important remark. If we put a point here, point B, x, y on the unit circle. So we know that the radius of the unit circle equal 1. So OB equals 1. So if we draw the right angle triangle BOZ or BOA, here we are going to put A. If we are going to draw a right angle triangle OAB, the distance OA will be x and the distance AB will be y. Okay, and this is the right angle triangle. You can see that x belongs to the interval from negative 1 to 1, and also y belongs to the interval from negative 1 to 1. Okay, you can see from the unit circle this point is 0, 1 and 0, and this point is negative 1 or 0. So x belongs to the interval from negative 1 to 1. And what about y? Here the point of intersection here is 0 and 1, and here the point of intersection is 0, negative 1. So the largest value of y is 1 and the smallest value of y is negative 1. So x belongs to the interval negative 1 and 1, and y belongs to the interval negative 1 and 1. Here, very important rule. We have an important rule in this lesson. What is it? By using the right angle triangle and by using Pythagoras theorem, you can show that here you have x power of 2 plus y power of 2 equals the hypotenuse power 2. What is the hypotenuse? The hypotenuse is OB for all power of 2. But OB is the radius of the circle, the radius of the unit circle. So you can see that x power of 2 plus y power of 2 equals 1. So this is an important rule in this lesson, that x power of 2 plus y power of 2 from Pythagoras theorem equals 1. Okay? And this rule we are going to use it in solving the problem of this lesson. Okay, let's go to another idea. The basic trigonometric functions and their reciprocal. Here, this is a new part for you. the basic trigonometric functions and their reciprocal. In the previous year, in third prep, you took the basic trigonometric functions, which are sine and cosine and tan. But today we are going to talk about the reciprocals of the basic trigonometric function. Okay? First, if we draw the directed angle AOB, if we draw the directed angle AOB, here the directed angle, its vertex is the origin point and its initial side is the positive direction of x-axis. And here the angle AOB, this is an angle in the standard position. You can see that this angle in the standard position intersect the x-axis at the point x and y. So if we draw the directed angle AOB in the standard position and its terminal side intersect the unit circle at the point B, x and y. Okay, so intersect the unit circle at the point B, x and y. And if measure of angle AOB equals theta. Here, if we draw the right angle triangle here, again, if we draw the right angle triangle here, we have a right angle triangle like this. This is B and this is the right angle triangle, okay, 90, and this is the directed angle theta. So this distance from the origin point to here, it will be x, and this is will be y. Okay, so let's talk about cosine theta. Here the hypotenuse OB, this is the radius of the unit circle, which is equal to 1. So what about sine theta and cosine theta? We all know that sine theta equals opposite over hypotenuse and cosine theta equals adjacent over hypotenuse, or you can remember by سوى كاتو، which means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. So from the right angle triangle, let's find cosine the angle theta. The cosine of the angle theta equals adjacent x over hypotenuse equals 1. So it will be x over 1, which is equals to x. And sine theta here equals opposite over hypotenuse. The opposite is y over 1. So it will be equals to y. Okay? By using the unit circle and by using the right angle triangle drawn in the unit circle, you can replace x by cosine theta. So here x will be replaced by cosine theta and y will be replaced by sine theta. And what about tan theta? We all know that tan theta equals y over x, or you can say equals sine theta over cosine theta. So tan theta equals y over x, or opposite over adjacent, or which is equals to sine theta over cosine theta. All of this will be equals to tan theta. Okay? So here we will replace x by cosine theta and we will replace y by sine theta. So any point whose coordinates are x to y, we can write it in the form x will be equals to cosine theta and y will be equals to sine theta. And by using the unit circle, we know that x power of 2 plus y power of 2 equals the hypotenuse power of 2. So x power of 2 plus y power of 2 equals the hypotenuse power of 2. This is a unit circle, so the radius equals 1. Replace x power 2 by cosine square theta replace y square by sine square theta, and this result will be equals to 1. Okay? Okay, let's go to another idea. Again, the basic trigonometric function in the right angle triangle. Here in this triangle, we have an angle theta, and this side is the opposite side, and this side will be the adjacent side, and the side opposite to the right angle is called the hypotenuse. Okay? Sine theta equals opposite over hypotenuse. Okay? Let's name this triangle first. Here, opposite is AB, B, and C. So sine theta will be equals to sine opposite over hypotenuse. Cosine theta will be adjacent over hypotenuse. CB over AC. And tan theta will be equals to opposite over adjacent. Today we are going to talk now about the reciprocal of the trigonometric function. The reciprocal of the trigonometric function will be sine theta equals opposite over hypotenuse. The reciprocal of sine theta, is called cosec theta. Sine theta, its reciprocal is cosec theta. And cosec theta equals 1 over sine. This is what we mean by reciprocal. We have sine theta, its reciprocal is cosec theta, and the cosec theta equals 1 over sine theta. And this is equals to hypotenuse over opposite. You know that sine theta equals opposite over hypotenuse, so cosec theta will be equals to hypotenuse over opposite. And what about the reciprocal of cosine theta? The reciprocal of cosine theta will be equals to sec theta. So the reciprocal of cosine is sec theta. And what about the reciprocal of tan theta? The reciprocal of tan theta equals cotan theta. So I will write it again for you. Here, this is sine theta. So its reciprocal will contains the two letters C and O, co. So sine theta, its reciprocal is cosec theta. And the cosine theta, its reciprocal, this is in the cosine, we have the two letters, cosine. So its reciprocal will be without co. So it will be sec theta. Okay, cosec theta and sec theta. Okay, here another way to write cosec theta, CSC, cosec theta. This is another way for writing cosec theta. And the reciprocal of cosine is sec, and the last one, the reciprocal of tan theta is cotan theta. You have to memorize it very well, very well. He will going to ask you about the reciprocals of the trigonometric function. Okay, let's go to another idea. This is the unit circle, and the unit circle intersect x-axis at the 2 points 1, 0 and negative 1 and 0, and intersect y-axis at 0, 1 and 0, negative 1. Again, if we want to find, here I'm going to put, if the standard, if the directed angle in the standard form, make an angle 0 with x-axis. So here we can write 0. And here the standard, the angle in the standard form, make an angle 90 with x-axis. And here it will be 180, and here the last one will be 270. And if the angle make one full turn, it will be 360 degree. Okay, so if we are going to talk about theta equal 0, theta equal 0, the first order pair is cosine theta. So this is cosine theta, and y will be sine theta. Okay, so here cosine theta cosine 0 equals 1 and sine 0 will be equals to 0. So here you can find that cosine 0 equals 1 and sine 0 will be equals to 0. And what about tan theta? Tan 0, if we want to find tan theta here, tan theta will be sine theta over cosine theta. So it will be here 0 over 1, which is equals to 0. So the trigonometric function of the angle 0 is cosine 0 equal 1, sine 0 equals 0, and tan 0 equals 0. What about the 90-degree angle? The 90-degree angle here, if the angle in the standard position makes an angle 90, so it intersects the y-axis at the point 2.0 at the point 0, 1. The first projection is x and second projection is y. X were replaced by cosine theta and y were replaced by sine theta. So cosine 90 will be equals to 0, sine 90 will be equals to 1, and tan theta will be equals to sine over cosine, which is equals to 1 over 0. And 1 over 0 here is meaningless or undefined. Okay? What about cosine 180 and sine 180? Here you can see that cosine 180 equals negative 1, sine 180 will be equals to 0, tan 180, y over x, 0 divided by negative 1, which is equals to 0. And again, 270, its cosine 270 equals 0, sine 270 equals negative 1, and tan 270 will be equals to negative 1 over 0, which is undefined or meaningless. Okay? And the last one, 1 over 0, the last one, which is angle of measure 360, and this is will be equals to 1, cosine 360 equals cosine equals 1, and sine 360 equals 0, the same as the trigonometric function of the angle 0. Okay? Another idea. The sign of the trigonometric functions, or you can say asterisk rule. Asterisk, ASTC, the abbreviation of asterisk rule. So let's go and study the asterisk rule. Here you can see that here we have the 4 quadrants: the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay? In the first quadrant, you can see that in the first quadrant, here, this is the first quadrant. Okay? In the first quadrant, x is positive, which means x bigger than 0, and y is also positive. So x is positive and y is positive. X means cosine, so in the first quad, cosine theta is positive, and y bigger than 0, which means that sine theta is also positive, and tan theta equals sine over cosine. Okay, positive divided by positive, it will be also positive. So in the first quadrant, all the trigonometric function is positive. So we will write A. All the trigonometric functions are positive. In the second quadrant, you can see that in the second quadrant, x here is negative. X here is negative, and the y-axis is positive. X smaller than 0, so cosine theta is negative, and y bigger than 0, so the sign of sine theta will be positive, and tan theta equals sine theta over cosine theta, which is positive divided by negative, so the sign of tan in the second quadrant is negative. So here we are going to write in this quadrant sine S. So in the first quadrant, all the trigonometric functions are positive. In the second quadrant, only sine and its reciprocal only sine and its reciprocal. So what is the reciprocal of sine theta? The reciprocal of sine theta is cosec theta. Okay? So in the second quadrant, only sine and cosec are positive, and the rest of the trigonometric functions are negative. Okay? In the third quadrant here, in the third quadrant, let's talk about the third quadrant. Okay? Here in the third quadrant, you can see that here in the third quadrant, x here is negative and y is also negative. So in the third quadrant, x smaller than 0, x means cosine theta, its sign will be negative. And y smaller than 0, so sine theta is negative. Tan theta will be sine theta divided cosine theta, negative divided negative. Negative divided negative, it will be positive. And the last quadrant is the fourth quadrant. Here in the fourth quadrant, x bigger than 0, so cosine theta is positive. Y smaller than 0, so sine theta is negative. Tan theta, negative divided positive, will be negative. So again, in the first quadrant, all the trigonometric functions are positive. All the trigonometric functions are positive. Sine, cosine, tan, sec, cosec, cotan, all of them are positive. In the second quadrant, sine only and its reciprocal, which is cosec theta, is positive. Sine and cosec are positive, and the rest of the trigonometric function will be negative. In the third quadrant, asterisk, so t here, tan and its reciprocal is positive. Both of them are positive. T and its reciprocal, which is cotan theta, are positive. Tan and cotan are positive, and the rest of the trigonometric functions will be negative. In the last quad, or in the fourth quad, cosine theta is positive and its reciprocal. What is the reciprocal of cosine theta? Excellent. The reciprocal of cosine theta is sec theta. So cosine theta and sec theta, both of them are positive, and the rest of the trigonometric function are negative. So we can write it in a simple way here. In the first quadrant, A, second quadrant, S and its reciprocal, tan and cotan, cosine and sec. So this is the asterisk rule. Okay? Let's go to some examples to explain what we have studied. Example 1. Determine the sign of each of the following. Here we want to determine the sign of each of the following angles. 350. First, 350 lies in what quadrant? Here, 350. 350 is bigger than 270 and smaller than 360. So, 350 is bigger than 270 and smaller than 360. So, 350 lies in the fourth quadrant. And in the fourth quadrant, asterisk. In the fourth quadrant, cosine theta is positive. Cosine theta is positive. So the sign of cosine 350 will be positive. Okay? Another example. Tan 100. Tan 100. 100 is bigger than 90 and smaller than 180. 100 bigger than 90 and smaller than 180. So angle of measure 100 lies in the second quadrant. But in the second quadrant, sine theta and cosec theta are positive. So tan here is negative because it is in the second quad. Okay, so the answer will be negative. The sign of tan 100 is negative. We mean by the sign of the trigonometric function positive or negative. Only we just want to know its sign, where it will be positive or negative. So tan 100 will be negative. Sec 265. 265 lies in the third quadrant. In the third quadrant, tan and cotan are positive, and the rest of the trigonometric functions are negative. So sec 265 is negative. Example 4, sine 65. 65 lies in the first quad, and in the first quad all the trigonometric functions are positive. So in the first quad it will be positive. Cosine 147. 147 is bigger than 90 and smaller than 180. So the angle of measure 147 lies in the second quadrant. In the second quadrant, sine and its reciprocal, which is cosec, are positive. So cosine here is negative. Tan 108. 108 lies in the second quadrant. In the second quadrant, the sine and cosec positive. So tan theta will be negative. Here, cosec 224. 224. Here, again, for you, 224. Bigger than 180 and smaller than 270. So 224 lies in the third quadrant. Let's go to the third quadrant. In the third quadrant, tan and cotan are positive, and the rest of the trigonometric functions are negative. So here cosec will be, its sign will be negative. Sine 5/4 pi. First, you have to change it into degree. Measure 5/4 pi, so it will be 5/4, and we will replace by 180, because we all know pi in the radian measure equals 180 degree in the degree measure. So we are going to multiply 5/4 by 180, and it will be 225. 225 bigger than 180 and smaller than 270. So 225 lies in the third quad, and its sign will be negative. Sine theta will be negative. Okay. Another example. This is another idea in this lesson. Here we have the point B. Let the point B x and 0.5 be the point of intersection of the terminal side of a direction angle theta in its standard position with the unit circle, where theta bigger than 90 degree and smaller than 180 degree. Find cosine theta and tan theta. Okay? So if you find in the problem that the point B, here you can see that the point B x and 0.5 is the point of intersection of the terminal side of the directed angle theta with the unit circle. So if this point is the point of intersection with the unit circle, so we are going to write it B equals to x and 0.5. Here x is the cosine, and we are going to replace x by cosine theta and y by sine theta. Okay? So by using the rule, x power of 2 plus y power of 2 equals 1, which is the point of intersection of the unit circle with the x-axis and y-axis. from the previous examples, we know that x power of 2 plus y power of 2 equals 1. Here we are going to write x power of 2 as it is, and y here equals 0.5, so it will be 0.5 for all squared equals 1. Here x power of 2 plus 0.5 power of 2, which is equals to 1 over 4, this is equals to 1. 1 over 4 will go to the other side, so x power of 2 will be equals to 1 minus 1 over 4. 1 minus 1 over 4, it will be equals to 3 over 4. Here x will be positive or negative, the square root of 3 over 4. By using your calculator, the square root of 3 over 4 equals positive or negative root 3 over 2. Now x has two values, 3 over 2, root 3 over 2, and negative root 3 over 2. Which one of them is the right value of x, the positive or the negative? Here we have another condition. Here theta bigger than 90 and smaller than 180. That means that the directed angle here lies in the second quadrant, bigger than 90 and smaller than 180. So in the second quadrant, we all know that by using the asterisk rule, in the second quadrant sine is positive and cosine theta here is negative. So where x will be replaced by cosine theta, so x will be the negative root 3 over 2. Now we are going to write the point B, which is equals to x and half. X will be negative root 3 over 2, and y, which is equals to half. Here we want to find cosine theta and tan theta, but I am going to find all the trigonometric function first. Here cosine theta, which is the x part, will be negative root 3 over 2. Sine theta, which is the y part, equals half. Tan theta, which is y over x, so we will divide half divided negative root 3 over 2, so it will be negative 1 over root 3. Or if you use your calculator, it will be equals to negative root 3 over 3. So what is the reciprocal of cosine theta? The reciprocal of cosine theta is sec theta. So sec theta will be the reciprocal of negative root 3 over 2. It will be negative 2 over root 3. And what is the reciprocal of sine theta? The reciprocal of sine theta is cosec theta. So it will be equals 2. The reciprocal of 1 over 2, it will be 2 over 1, which is equals to 2. And the last one, what is the reciprocal of tan theta? The reciprocal of tan theta is cotan theta. Here tan theta equals negative root 3 over 3 or negative 1 over root 3. If we want to find the reciprocal, it will be negative root 3 over 1, which is equals to negative root 3. Now we find all the trigonometric functions of this angle which intersect the unit circle at the point x and 0.5. But here we want to find cosine theta and tan theta. So here cosine theta will be negative root 3 over 2 and tan theta will be equals to one of the two values, negative 1 over root 3 or negative root 3 over 3. Okay, let's solve it again by using the PowerPoint. We are going to solve it by using the PowerPoint very quickly. Okay, solution. Here x power of 2 plus y power of 2 equal 1. So x power of 2 plus 0.5 for all power of 2 equals 1. X power of 2, the square of 0.5 will be 1 over 4 equals 1. X power of 2 equals 1 minus 1 over 4. It will be 3 over 4. So x equals positive or negative, the square root of 3 over 4, it will be positive or negative root 3 over 2. Okay, so this is here positive or negative. Since theta is bigger than 90 and smaller than 180, so cosine theta lies in the second quad, theta lies in the second quad, and in the second quad cosine is negative, so cosine theta will be negative root 3 over 2. Okay, so now we can write the point B will be equals to cosine theta, which is x, negative root 3 over 2, and 0.5. And if we want to find tan theta equals y divided by x, so it will be half divided by negative root 3 over 2, it will be equals to negative 3, as we solved it before. Okay, let's go to another example. Suppose the point 3a and negative 4a on the unit circle. So he told us that 3a and negative 3a and negative 4a lies intersect the unit circle. Here the angle, the directed angle intersects the unit circle at the point B, 3a and negative 4a. Determine a directed angle theta in its standard position where a bigger than 0. This is an important condition, that a bigger than 0. Find all the trigonometric functions for theta. Okay, let's solve it together first. Solution. By using the rule x power of 2 plus y power of 2 equals 1 from the unit circle. X 3a, so 3a for all power of 2 plus y negative 4a for all power of 2, this is equals to 1. 3a for all squared will be 9a power of 2, negative 4a for all squared will be positive 16a squared, all of this equals 1. By adding 9a squared plus 16a squared, it will be 25a squared equals 1. Divided by 25, so a power of 2 will be equals to 1 over 25. So a will be equals positive or negative 1 over 5. But the second condition is a bigger than 0. Here we have a bigger than 0. A bigger than 0 means that a is a positive quantity. So a will be equals to 1 over 5. Okay, let's write the point B. Now the point B will be 3a. 3a means 3 multiplied by 1 over 5, it will be 3 over 5. And negative 4a, negative 4a means negative 4 multiplied by 1 over 5, which is equals to negative 4 over 5. Here we want all the trigonometric functions for theta. So cosine theta will be equals to 3 over 5. Sine theta will be equals to negative 4 over 5. Tan theta equal sine over cosine. Here it will be negative 4 over 3. So what is the reciprocal of cosine theta? The reciprocal of cosine theta is sec theta equals 5 over 3. The reciprocal of sine theta is cosec theta, which is equals to negative 5 over 4. And the last one is the reciprocal of tan theta, which is cotan theta. Cotan theta equals negative 3 over 4. Okay? So this is the answer of the question. Let's solve it again by using the PowerPoint. Solution. 3a for all power of 2 minus 4a for all power of 2 equals 1. So 9a for all power of 2 plus 16a for all power of 2, and this is equals to 1. Okay, 25 a power of 2 equals 1 divided by 25. So a equals positive or negative 1 over 5. But we know that a bigger than 0, so a equals 1 over 5. A bigger than 0 is given in the problem. So a equals 1 over 5. Now we are going to write the point B, which is equals to 3 over 5 and negative 4 over 5. Cosine theta equals 3 over 5 and its reciprocal is sec theta. The reciprocal of cosine is sec theta, not cosec theta. So we are going to remove cosine, the two letters co. The reciprocal of cosine theta is sec theta and it will be 5 over 3. Okay, sine theta equals negative 4 over 5. Its reciprocal is cosec theta, which is equals to negative 5 over 4. And the last one, tan theta, sine over cosine, negative 4 over 5 divided 3 over 5 equals negative 4 over 3. So the reciprocal of tan theta is cotan theta equals negative 3 over 4. Another example. Again, negative x and the negative x. The point B is negative x and negative x, where x bigger than 0. So the value of x is positive, but if we multiply it by negative, it will be negative. So we want to find the value of x, which is a positive part. Okay, let's solve it together by using the rule. X power of 2 plus y power of 2 equals 1. Negative x power of 2 plus y here is also negative x. So it will be negative x power of 2 equals 1. Here x power of 2 plus x power of 2 equals 1. So 2x power of 2 equals 1. Divided by 2, x power of 2 equals half. By taking the square root, x equals positive or negative 1 over root 2. 1 over root 2 by using your calculator, it will be equals to root 2 over 2. Okay? So now we have x is positive or negative, root 2 over 2. But here x is bigger than 0. This is the given in the problem, that x bigger than 0. So we will choose that x equals root 2 over 2. So x equals root 2 over 2. So we can write b now. B equals to negative x and the negative x. So it will be negative root 2 over 2 and negative root 2 over 2. So now we are going to find all the trigonometric ratios or trigonometric functions. Cosine theta equals negative root 2 over 2. What is the reciprocal of cosine theta? Excellent. The reciprocal of cosine theta is sec theta, which is equals to negative 2 over root 2. Put it in the simplest form, it will be equals to negative root 2. So sine theta, which is represent the y coordinates, equals also negative root 2 over 2. And sine theta, its reciprocal is cosec theta, equals also negative root 2. The last one, tan theta, equals negative root 2 over 2 divided by negative root 2 over 2, which is equals to 1. So the reciprocal of tan theta is cotan theta, which is equals to 1. You can see if you use your calculator, tan theta equals 1. Okay, tan theta equals 1 and cotan theta will be also equals 1. Okay. Okay, let's go to another example. Here the steps again by using the PowerPoint. Sine theta equals negative 1 over root 2 cosec theta, it will be equals to negative root 2. Okay, and the last one, tan theta equals negative 1 over root 2 divided by negative 1 root 2 equals 1, and its reciprocal is cotan theta equals 1. Another example, a point B intersect the point B, 9A and 12A intersect the unit circle where theta is bigger than 180 and smaller than 270. Here, what we mean by theta bigger than 180 and smaller than 270. Theta bigger than 180 and smaller than 270 means that theta lies in the third quadrant. Theta lies in the third quadrant. Again, in the third quadrant, asterisk rule. In the third quadrant, tan and cotan are positive, but all the trigonometric functions are negative. So in the third quad, tan and cotan are positive, and all the trigonometric functions are negative. So sine, it will be negative, cosine will be negative, tan positive, cotan will be positive, sec and cosec will be negative. Okay? Okay. Here we all know that x power of 2 plus y power of 2 equals 1. So 9a for all power of 2 plus 12a for all power of 2, this is equals to 1. 9a for all power of 2 equals 81 a power of 2 plus 144 a power of 2, this is equals to 1. By adding 81 plus 144, it will be 225 a power of 2 equals 1. Divided by 225, so a power of 2 equals 1 over 225. By taking the square root, so a equals positive or negative square root of 1 over 225, which is equals to positive or negative 1 over 15. Which one of them is correct? Positive 15 or negative 15? Here, cosine and sine, both of them are negative. Both of them are negative. So a will be equals to negative 1 over 50. Now you can write the point B as 9a, 9 multiplied by a, which is equals to negative 9 over 15. And 12a will be equals negative 12 over 50. Put it in the simplest form, so b equals negative 3 over 5 and negative 12 over 15, put it in the simplest form, it will be negative 4 divided by 4, it will be equals to, divided by 3, it will be equals negative 4 over 5. Now you have the point B, so you have all the trigonometric function. Cosine theta will be equals to negative 3 over 5. Its reciprocal is sec theta equals negative 5 over 3. Sine theta, it will be equals to negative 4 over 5. The reciprocal of sine is very good, is cosec theta, which is equals to negative 5 over 4. Tan theta will be equals to sine theta divided by cosine theta. So it will be 4 over 3, and the reciprocal of tan is cotan theta, which is equals to 3 over 4. Okay? Okay, let's solve it very quickly by using the PowerPoint. Nine a power 2 plus 12a power of 2 equals 1. 81 power of 2 plus 144 a power of 2 equals 1. So 225 a power of 2 equals 1. A power of 2 equals 1 over 225. Taking the square root, a equals positive or negative 1 over 15. But theta lies in the third quadrant. That is to say that cosine theta is negative and sine theta is negative, which means that a equals negative 1 over 50. So b equals 9 multiplied by negative 1 over 15 and 12 multiplied by negative 1 over 15, which is equals to negative 3 over 5. and the negative 4 over 5 after putting them in the simplest form. Here cosine negative 3 over 5, the reciprocal of cosine is sec negative 5 over 3. Sine theta negative 4 over 5, the reciprocal is cosec theta negative 5 over 4. And the last one is tan theta negative 4 over 5 divided by negative 3 over 5. It will be equals to 4 over 3. So cotan theta will be 3 over 4. Okay. Don't forget that we can write cosec theta by using two ways. Okay. You can write it as cosec theta, or you can write it in abbreviation form, which is cosec theta. Okay. Okay. The last example and last idea in this lesson. If x belongs to 0 and 90, find the value of x that satisfy sine x multiplied by sec square 45 equals tan square 60 minus 2 cosine 360. Okay, let's solve it together first. Here sine x, we don't know the value of x, so we will write sine x. Sec square 45. What about sec square 45? The calculator can't find the value of sec or cosec or cotan. But here we know that sec is the reciprocal of cosine. Sec is the reciprocal of cosine. So we can write sec square 45 by 1 over cosine 45 for all square. Here this is sec square 45. You can write it as 1 over cosine 45 for all square. And this is equals to tan square 60. Tan square 60 equals tan 60 for all power of 2 minus 2 cosine 360 minus 2 cosine 360. We know that from the unit circle that cosine 360 equals 1. I will draw the unit circle again for you. Here this point is 1 and 0, and here is negative 1 and 0. Here 0 and 1, and here is 0 and negative 1. Where is 360? 360 here is the point of intersection of the unit circle with x-axis. This is 0 or 360 degree. So cosine 360 is equals to 1. So I will write 1. Now, here by using your calculator, sine x multiplied by 1 over cosine 45. Cosine 45 equals root 2 over 2. So it will be 1 over root 2 over 2 for all square equals tan 60. Tan 60. By using your calculator, tan 60 will be tan 60 equals root 3. So write root 3 for all power of 2 minus 2 multiplied by 1, which is equals to 2. Here root 3 power of 2 equals 3. 3 minus 2, this is equals to 1. Here we have sine x and 1 over root 2 over 2 square. It will be equals to 1 over 2 over 4, which is equals to half. So sine x multiplied 1 over half, which is equals to 2, equals 1, divided by 2. So sine x will be equals to 1. By using your calculator, sine x equal 1. So x will be shift sine 1. By using your calculator, shift sine 1. So sine x will be equals to 30 degree. Okay. Here x equals 30 degree or 180, because sine 30 equals 1 and sine 150. Okay, or x equals 150. Sine 30 equals 1 and sine 150 equals 1. But here we have a condition that x belongs to 0 and 90, so 150 will be refused and the answer will be x equals 30. Okay? Again, we can solve it one more time by using the PowerPoint very quickly. Solution. Here, sine square x, sec square x, sec square 45, tan square 60 minus 2 cosine 360. Okay? Here, sine x remains as it is. Sec 45, don't forget that sec 45 equals 1 over cosine 45 and for all power of 2. Okay? So it will be root 2 over 2, root 2 power 2. Tan square 60 will be equals to root 3 for all power of 2 minus 2 cosine 360, which is equals to 1. So here 2 multiplied by sine x equals 3 minus 2 equals 1. So sine x divided by 2, sine x will be equals to half. Shift sine half, so x will be equals to 30. This is the end of our lesson today. One of the important lessons in trigonometry and one of the fundamental lessons to complete our sessions in trigonometry. So you have to study it very good and very carefully. Thank you so much. Until we meet again next time, goodbye and good luck.